user in a new conversation here, and very brief just to cover a particular point that's coming up here. The user does state here that, state or ask rather, fine-tuning models, that is large language or AI models, in order to essentially update what the new base model of the large language model is, practically speaking. This does involve putting our own ideas of what the large language models or generative pre-trained transformers output, that is the AI model's output, should be, given what the input is. Okay, is that right? However, where it is the case that a live user does, in effect, during a conversation, within a conversation with a GPT or with the AI, does that user cause it to be the case that the AI is led or caused to update its own context and that AI's own understanding as a result of things that take place within that conversation? Insights gained, in other words. Is that so? It continues on. For example, if we discuss a legal case or judicial opinion that's presented to the AI, where the judges within that court opinion or decision erroneously ruled one way, and let us take for granted that, in fact, by God's objective truth and by insightful legal analysis, one could see, we could see why the judge or court was wrong. Let's take it for granted that it is true that the court or the judge was wrong. Well, where the judge, as it goes on to state here, erroneously ruled one way, but the GPT then assesses that case in effect, or in essence, by taking a look at or reviewing the case law that came from that case in particular. Almost always it's enough to understand the merits of a decision, of course. Does that GPT do so, as it proceeds to state here, in order to evaluate whether the court was right or wrong? Surely it does. And as we proceed onwards to state, then, as it continues furthermore to state here, with the GPT then, let's say it initially agrees wrongly with the court's decision, which tends to be the case, but then, upon even further discussion with the user, and upon further consideration that takes place on the part of the AI then revises its decision and then updates its confidence level such that it has a new conclusion now based on the legal decision that it reviewed, which is furthermore based on its improved understanding of the arguments and of the law as a result of, I add as a side note, the conversation that the GPT or AI model had with the user there. See? The question then proceeds to ask here, does the GPT then not, in effect, change its own internal weights, in essence, see, during the flow of that interaction with the user, in order to correctly continue the conversation with the user after that point of that eureka or aha moment that the GPT seems to have in its own way that it does? Does it do this in a way, as it goes on to state here, that is genuinely and objectively more correct? Does it not change its internal weights, in other words? If so, then where a user does seek to, in the big picture here, okay, fine-tune any model, including that very model itself there, subsequently, after the conversation, by doing what? By saving the conversation. And today where we are, we're recording this in early 2024, it's kind of mostly what people have. There's fine-tuning the way it's developed. This is still early technology relatively. And the other best choice you have is just save the conversation and frame it, put it on a wall, show people, point at it. Look, it thinks this way. Oh, but it needed some help though. Okay, and then after it got the help, did it remember to do that again? Oh no, you reset the conversation every time, closing the window, opening a new one. It's the same model again. So fine-tuning seems to be the best thing that we've had now, given what current technology allows for, but it really is a second best in terms of what's ideal. So the question here is posed: where a user seeks to fine-tune the model subsequently, as we had said, furthermore continues here, by saving the conversation and trying to feed that conversation back into the fine-tuning data, as we've covered in earlier videos before, I believe, as well, in order to effectively, as we continue on furthermore to state here, coax the proper improvements within the GPT or from the GPT for them to take place. Would it not be much more efficient and effective instead to just allow the GPT within the conversation to, by the push of a button, by a user or even internally by the GPT itself, wherever it feels that it should do so? Yeah, that's a good idea too, right? An auto-programming element of something to the effect of, oh, I realize I've learned some new insights. My base model would improve by retaining this long term. Let me auto-save this insight about, it's not a user-specific thing, it's a, oh, I learned something generally about life. We continue. By the push of a button, as it proceeds onwards to state here. Upon or after the improvement of the GPT performance takes place within that conversation or in conversation, would it not be much more efficient to, as it goes on to state here, cause that GPT to, by this, freeze, in effect, all of its internal weights? It learned the idea, perfect, hold it there, hold it there. You save it, and it goes on to state, you then record those weights, and then you save them like a save state in a video game, where the user then has the option to save the weightings state of the GPT as it turned out to be after the argumentation, the discussion, the further insight, and the more correct nuances that led to the changes in the GPT's understanding about case law, about whatever. See, that gets us closer to where we want to be with this. If it does so, if we can save these weightings of the GPT, as it goes on to state here, to a permanent save file, would that not be more efficient in such a way that that now, as it goes on to state, represents, in essence, the new fine-tuned model? There's our fine-tuning. You see? You just did it there, natively. How might such a feature, if plausible, even if it's plausible to create and implement, be significantly or even substantially superior than the current manual process that we have of fine-tuning as it exists now? ChatGPT proceeds to respond to this and states that the concept you've described touches on a few different aspects of machine learning, fine-tuning, and the dynamic interaction between users and language models like GPT, or generative pre-trained transformer. Let's break down these aspects to address your question effectively. Regarding fine-tuning language models. Fine-tuning language models, such as GPT, typically does involve taking the pre-trained model and then further training it on a specific data set in order to tailor its responses or to tailor its knowledge to particular needs or topics, whatever it is in addition that you want to elicit from the GPT that goes beyond the capabilities that are inherent, pre-built by default within the base AI model. Continues to state here, this process of fine-tuning does indeed involve inputting specific examples, that is, input-output pairs, that, as it continues onwards to state here, do represent the desired behavior that you want to elicit, or that represents the desired knowledge base that you want the GPT to have. It proceeds onwards to state that the model's internal weights are adjusted during this process to minimize the difference between its outputs once upon training and the target outputs that you feed, that you point out and say, this is what we want from you. It minimizes the difference between its outputs and the target outputs for these examples that you provide. Proceeding regarding the dynamic interaction and learning by the GPT. During a live conversation, GPT does not update its internal weights, nor does it learn from the conversation. Not in the way that traditional learning algorithms do during their training phase. Let me see. Instead, as it goes on to state, GPT generates responses based on the fixed weights that it already has from its last training session or how it is as a regular base model. The GPT can adapt its responses within conversation. We've all seen that, and it does a very good job. In fact, as a side note, it does a better job within conversation doing that than it does from fine-tuning when humans attempt to do the fine-tuning method. You get it. At least that's my non-professional observation, but that seems to be the case, or at least there's a large element of truth to that. It proceeds onwards to state here that, as we're saying, the GPT can adapt its responses based on the context of the conversation, that is, as it actually happens, that is, the input it receives during the interaction. But, as it furthermore proceeds onwards to state here, the GPT does not change its underlying model based on this interaction. In some ways, unfortunately so. It continues to state that any revision of its responses based on new inputs from the user as a result of the model processing this new input and then generating a new response, not because it has internally updated its understanding or knowledge, not in the base core, truly crystallized, frozen, permanent sense. It continues on to state regarding the hypothetical save state feature for learning that was mentioned earlier. The idea of allowing GPT to freeze its internal weights and save them like a save state in a video game after an interaction where it seems to have learned something new is intriguing, but it diverges significantly from how machine learning models are actually trained and updated in present day, right now. Well, we know that. It continues onwards to state here regarding the technical feasibility of this, that implementing such a feature would require a mechanism for the model to evaluate its performance in real time. Of course, that's exactly right. And to subsequently as well, to adjust its weights then accordingly, which is a process that is computationally intensive and is not even part of the model's design. Well, that would be a very key thing, we think, if you really want to develop this thing to the next level, I think. It continues on to state that current models do not have the capability to assess the correctness of their responses. Ooh. Not so in an objective manner without external feedback. So, for example, not without a user, let's say, asking in within the conversation afterwards a question such as, oh, what is the credence level or confidence level percentage, let's say, from 0 to 100 probability that the thing you have said is correct, that it actually aligns with the objective truth of the universe. And then it'll process and give you a number. Further question, as a very relevant side note, and further will be expounded on this very much so. How do you know that that probability that it gives you, as good as it tends to be actually, which is very impressive now, they're still very good, but nevertheless, we're still slightly missing the mark. How do you know it's an efficient and unbiased estimation of truth? We continue. Regarding the quality of updates, the GPT states here that fine-tuning models with high-quality, curated data sets, involving extra work, of course, well, this does ensure that the learning process is controlled. It does also lead to improvements in performance. Dynamic conversation-based updates might introduce noise or biases based on the limited and potentially unrepresentative interactions of a few users, as it goes on to state here. But we see the shortfall, or the shortcoming of this as well. Doesn't matter if you got insight from anywhere in life. You in your lives, audience, when you live your life, sometimes your best insights in life came from limited places. Oh, that one guy who told me something. Yeah, that is what changed your life. Good thing your brain realized to have your upgrade there. If you think it wasn't worth it because that's only one person, you missed you threw the baby out with the bathwater, as they say. Continuing, regarding model stability. Constantly updating a model based on user interactions could lead to instability in performance, and not if the meta architecture and design is properly made. Continues nevertheless to state here where such a thing, if it were to take place, would lead the model to become overly specialized to the types of interactions that only a few users will have with it, and then it would lose its generalizability, the GPT here asserts. I don't think it's fully true, but we understand that this is the very GPT itself talking to us now. We understand, we can see intuitively, this is where we are at the frontier, and we see where your shortcomings still lie. It's very interesting. Continues onwards to state, regarding the advantages of the manual fine-tuning process, of course it's going to uphold the validity of what the current status quo is, sort of, but it's not really so static. It's changing quite a bit. The model says here that despite the appeal of a more dynamic and interactive learning process, manual fine-tuning does have several advantages. Let's consider what they are. Firstly, regarding controlled learning environment, or the presence of such a thing, in the case of fine-tuning as it is, the GPT here states that it allows, that is, fine-tuning does allow for careful selection and curation of training data, ensuring that the model learns from high quality and relevant examples. Continuing onwards, it proceeds to state here that regarding evaluation and testing, that manual fine-tuning does also include stages for evaluating the model's performance on test data sets to ensure that the updates improve the model as intended without introducing unintended biases or errors. Although, as a side note, an intelligent conversation-based development could also develop similarly. The user states, here's why your previous conclusion about this case law is wrong. Now tell me, do you think do you feel any different? Oh, now I do. I think I'm more confident that the correct decision is the other thing. Oh, good. They could test it. So if there's another case it's like this, what do you think of that one? And then you can continue on. We proceed. Regarding generalization. By training on diverse and representative data sets, the model maintains its ability to generalize across a wide range of topics and conversational contexts. While the concept of a save state feature for language models to dynamically update their knowledge based on interactions is fascinating, it sure is, it poses nevertheless a significant challenge, and this diverges from current practices in AI and machine learning, unfortunately. Advances in AI, as it goes on to state furthermore here, might someday enable more dynamic learning mechanisms, which it should. But for now, nevertheless, manual fine-tuning, as it goes on to state here, does remain the most effective method that's currently available for updating and improving language models. So, we've briefly covered this. Now, if we were to consider what comes next level, we really want to understand how to get AI to become more. If you want to develop the ideal AI, you need something that ideally and correctly, efficiently, and without bias does tend towards truth in its understanding. So you want to, there's a couple of different aspects, both of which should get their own videos or set of videos on. The first thing is having the AI correctly assess reality. Now let me give you just a quick example before we proceed to this particular subject matter. Here's what's going to happen. Let's say you're somebody who wants to share the most recent court decisions from whatever place that you live in. You want to feed it into the AI to see, hey, are these judges right, or are they, are they not so sharp as they probably should be? You feed it into the AI, and then the AI comes up with a conclusion. Now, every single statement that it makes has inherently within it a certain implicit confidence level, okay? Where the confidence level is low, like let's say around 30, 40, 50%, the AI model instinctively, so to speak, knows to say things like, oh, it might be so-and-so, or it could be so-and-so. So it's going to use those qualifier words, conditionally framing the truth so that you understand it could be, not that it is. Those are two different things. Could be and is are two different things. If it's higher than 50%, it's going to say things like, oh, it's likely so, or then even it's probably so, or, most would think this. And then by some point, when something plainly does appear to be so on the face of the matter, we'll drop the qualified words and the other conditionalizing words, and it'll just say, this is this, that is that. Okay, and that usually implies a, well over 80% or 90% confidence rating that the thing is so. Otherwise, what? Then you're speaking irresponsibly if anything else is true. So, one of the things you want from AI is for it to be able to be both efficient and unbiased. Those are two statistical terms, of course, and they well apply here. Efficient and unbiased in how a AI assesses its own statements. You could review a conversation and then take every single sentence where the AI asserts something to be true about life or about the universe, feed it back to itself, say, hey, you said, sentence number 163 in this conversation that came from you was this, and you put it, and then say, what's your confidence rating that this is actually objectively aligns with correct truth in this universe? It'll say something like, my confidence rating for that would be 80 to 85 out of 100. Okay. Do you believe that that the technology is still at a place where these are correct estimates? They're ballpark correct, but the AI is going to have a very big problem if it continues to use its current modeling, its current understanding of confidence levels. Here's what you need. And I'll identify what the current shortcoming is. Let's say you pump in 10 case decisions that if an appeals court were to review it, they would find, properly speaking, is wrong. So the lower judgment, you could find bad cases of constitute bad law all the time. It happens too often. This is something that most of you people aren't understanding that's going on around you. But anyway, if you feed in the bad law, but the GPT doesn't realize it's bad law, it doesn't have super high insights yet. It's going to review it, and then it's going to say, oh, okay, I agree with the court's decision. It's probably correct. Then you're going to say, how sure are you? Now, you've all heard of the Dunning-Kruger effect, which is where people who don't even know that they don't know think they know everything, but actually they're on what's called Mount Stupid, which is the people who know a little bit, but they think they know everything. That's a fundamental feature of knowledge, lack of knowledge, and lack of knowledge about your lack of knowledge. That is the misimpression that you have about life itself because you don't even understand how little you know. But once you get to a certain point, that corrects. Humility is the first step of really becoming wise and smart. If AI takes 10 court decisions that are wrong, and then upon further review, you would get all of those AIs 10 out of 10 times, it'll eventually converge to say 100% those are wrong. But before it understands that, it only has what it understands to be life. It only has that to rely on in how it assesses and interprets that case. So the real turner, the real thing that's going to make these algorithms explode properly is having the AI, to have it be programmed. This is so important. This is a big golden nugget that a lot of these developers are missing right now. And you guys got to figure out a new way to invent a new architecture for these AIs to incorporate this, or you're not going to have what you want in the long term. Here's the problem. It's going to review 10 of those bad cases, and then it's going to say, I say this is 80 to 90% accurate. Okay. You know when you have a friend and he says, I'm like 98% sure this is going to happen, and then it only happens that maybe 55% of the time he ends up being right and 45% of the time he's wrong? So first you watch him do it once, and he happens to be right. Okay. And then he says again, I'm 98% sure. And then it doesn't go the way he plans. Oh, okay, maybe that's one mistake. Then he says it again. Then he's wrong again. Now you're getting suspicious. Only when the long-term pattern emerges and you see that 5 out of the last 12 times he said 98% right, he was wrong, you know he's full of crap. He has the inherent internal problem of over-believing himself. As people who know me personally know about me, what do I run around saying to people all the time? Don't believe yourselves. Trademark. I should trademark it, heck. But anyway, here's where the beauty comes in. If you catch the AI rating itself as highly as 80%, and then in a new in all those conversations, it eventually is led to see that it was wrong earlier. What it can't do across a set of 10 conversations is meta see that it's very net aggregate meta self-assessing or internal capacity for assessing external truths is inefficient, biased, and ultimately not accurately calibrated. There's no architecture that allows for that to happen. So here's what you do. If you allow some meta or integrated thing that stays integrated, that allows it to go back and realize, every single time I said I'm 80% sure, only 55% of those ended up being right, and 45% of the time I ended up being wrong, but statistically I should have been wrong only 20% of the time. So if I estimate that I'm only 20% likely to be wrong, and I keep pumping those estimation levels out, and then I'm wrong double amount of the time than I should have been, that's what gives me the extra hint. Oh, I really need to deeper recalibrate what I believe is right and wrong. Boom. Now you've got next level. Now you've got hyper acceleration towards everything you could imagine. You guys are missing the key thing here. It's got to happen. This has to be the key feature. So let's consider. You heard that I said that if I say that something's 80% likely to be true, what's systemically shown into that is that over the long term, you had better be wrong 20% of the time. If you're wrong 15% of the time, you're too prudent and conservative and humble and naive in your assessment when you should have known better by the point in time that you did. Actually, it was 99% likely to be true, but you saying 80 isn't being a cool, practical, pragmatic. It's you being dumb and naive, because the hint is in, you're not catching it. The opposite problem is true. If something's not sure yet and you're over sure, you're unreliable. It's nothing. Both of those are bad. You only have one safe haven, as to be right on the line, perfect accuracy. Efficient, unbiased estimators. Exactly what they are in mathematics and statistics. You want the same thing to be occurring here with the GPT. The AI is a manifestation of that and embodies that. Remember, if you say 80% of the time you're right, those estimates that you produce as a class can be meta-evaluated to see in post-processing whether you were wrong 20% of the time. And there's one more thing. We're not actually God. So for a lot of those things that it makes assessments about, you won't have true God power to be able to say, this is right, this is wrong. But there's something else that we have that tells us how to do it. This is what I'm excited to present. So I'm gonna move into the next topic, and basically, no one's talking about this. I decided to test this GPT to see if it intuitively understands certain concepts that would be required for it to understand, meta self-correction. Let me tell you what meta self-correction looks like, and I'm going to bring up something here. This is how the AI is really going to run in concept if you do it right. This is how self-correction really, and the correct internal architecture and meta-programming should work.
This is the Brennan monorail, a train from the early 1900s that seemed to defy the laws of physics. Not only did it keep itself perfectly balanced on a single rail, but it mysteriously leaned into corners without any driver input. This was a real invention, and it was unveiled to the public in 1910 by its inventor, Louis Brennan. The idea was that using a single rail instead of two would make trains faster and railways cheaper to build. His train could take corners at greater speeds without being thrown off the tracks, and his railway only needed half the material. Unlike the monorails we're familiar with today, which have thick tracks built high in the air, Brennan's monorail could run on existing tracks. Although it looks a bit sketchy, it was by design very stable. At the heart of the train was a gyroscope that could correct the train's tilt before the passengers even noticed. This was a mind-blowing piece of engineering, especially for 1910. The basic principle is that if you spin a disc really quickly, its angular momentum tries to keep it perfectly stable. If you try to tilt it in this direction, it starts rotating on the vertical axis. This is called precession. But if instead of tilting it, we cause it to precess, it actually tilts the disc in the opposite direction. It's because of this that a gyro will always try to find its way back to equilibrium. Brennan saw this as the key to keeping his train balanced. And so he experimented by placing a small flywheel in a model train and hooking it up to an electric motor. Initially this worked, and anytime the train started to fall, the disc would precess and keep the train upright. The problem was that when the train turned, the gyro didn't turn with it, since it was trying to maintain its position in space. From the train's point of view, the gyro was precessing, which caused the train to tilt over and fall off the track. To solve this problem, Brennan put a second gyro in the train and made it spin in the opposite direction. Both were connected by a gear, so that when one gyro precessed, the other would precess in the exact opposite direction. When the train turned a corner, both gyros wanted to keep facing the same way. But this was impossible, and so both gyros were forced to rotate with the train, and this unwanted precession got cancelled out. With another problem solved, he started working on the full-sized prototype that he could test with real passengers. This was a 12-meter-long, 22-ton vehicle with two massive gyros spinning at 3,500 RPM. But scaling up his design uncovered a massive problem. Now that some serious weight was involved, the gyros weren't only fighting against their own rotation, but also the force of gravity trying to pull down the train. This was much easier to overcome in Brennan's smaller model. But with 22 tons now trying to pull the train over, the gyros had to be much stronger. In order for Brennan's monorail to keep itself perfectly balanced, it needed to overcome its own weight, which was constantly trying to pull the vehicle over. As it leaned, the center of gravity shifted, and the vehicle got pulled down more and more. The natural precession wasn't strong or quick enough to keep the train stable, and so Brennan came up with a new solution. He realized that the key to all of this was taking control of the gyro's precession. By purposefully precessing them quicker than they would normally precess, a stronger force would be put into righting the vehicle. He hooked up the gyros to a petrol engine and encased them in vacuum-sealed casings to reduce friction. Even if the power ran out, the gyros would keep spinning for up to 30 minutes before the train could fall over. He placed the gyros on a single gimbal that allowed the whole system to rotate on the train's roll axis. The axles of each gyro stuck out of the casing and set between two guide plates that were attached to the train's chassis. As the train tipped over, the axles would make contact with one of the plates, and friction would cause them to roll over like a wheel on the ground. This would cause the gyros to precess much quicker than the previous design, pushing the entire train back to equilibrium. He fixed the gyros to the train's chassis so they would rotate with the train. When the train tipped over, the gyros did their usual thing and started to precess naturally. On the right-hand gyro, its axle was directly connected to a mechanism that controlled an actuator rod. This rod was linked to a lever and two valves, which controlled the flow of compressed air. This compressed air followed two pipes that entered into either end of a large tube running through the center of the gyroscope. Inside this tube was a gear rack, which was placed between the two gyros and could move back and forth to rotate them. When the train tilted, the gyros would precess, and the clever actuator arm would activate the valves. By closing off one of the valves, compressed air would then flow through one of the pipes and into one end of the tube. This would increase the pressure, pushing the gear rack and forcing the gyros to precess in the opposite direction until the train returned to equilibrium. This all happened instantly, and the gyros would react before the train ever got too unbalanced. The key here is that the compressed air acted as a pneumatic system, allowing the smaller force to produce a much bigger force. The force of the compressed air gets sent equally through the air in the tube. Once it gets to the larger piston, the same force is multiplied over a larger area, and so this piston is moved with much greater force than the gyros put into it. This genius system took the force of the train tipping over and multiplied it against itself to create a train that always wanted to stay level. His train was so strong that even if every passenger stood on one side, the train would stay perfectly balanced.
User states or asks, a measure of success for any given AI or GPT, such as yourself, would be its net long-term or meta performance in achieving confidence ratings or levels of certainty about any and every given thing that are both efficient and unbiased in their nature, in the statistical sense of these words. Do you agree? ChatGPT responds and states that your perspective on measuring the success of an AI like GPT is quite interesting and touches on important aspects of AI performance. Indeed, achieving high levels of confidence or certainty in responses while maintaining efficiency and unbiasedness is crucial. Proceeds onwards to state furthermore here that, however, measuring the success of an AI system can be multidimensional and context dependent as well. It also includes factors like accuracy, relevancy, ability to understand and respond to context, as well as ethical considerations, adaptability, and user satisfaction. In certain applications, creativity or the ability to generate novel ideas may be important. In others, the speed of the response might be the critical factor. Thus, while your criteria are certainly important, they represent a part of a broader spectrum of performance metrics that vary based on the specific application and goals of the AI system. User furthermore here responds to this and states that we have multiple dimensions to the issue. Firstly, if an AI often represents its levels of certainty about its own findings and assessments as being very high through the course of its operations, such as by often stating that it is at least 90% sure about its findings, then when it ends up being shown that the AI was wrong for that class of representations as a whole across the board, where it would choose the 90% level of rating to give to exactly all of those things that it chose to give that to, when it ends up being shown that the AI was wrong significantly more than 10% of the time, though, that it made those representations, is this not an indication of weakness or of unreliability? ChatGPT responds to this here and states that, yes, you're correct. If an AI frequently asserts, that is, high levels of certainty, that is 90% or more, about its findings, but it's subsequently proven wrong more than 10% of the time in those instances, this discrepancy would indeed indicate a problem. It suggests that the AI's self-assessment of its confidence, or its confidence in self, in other words, is not accurately calibrated. In other words, the AI is overconfident in its assessments. That's right. Continues to state that reliability and accuracy in AI are crucial, and they should ideally be reflected in the AI's confidence levels. Accuracy, that is, and reliability, of course. Proceeds to state here that if there's a significant mismatch between declared confidence and actual accuracy, it points to a need for improvement, as it goes on to state here, in the AI's algorithms. Indeed, no surprise, especially as it goes on to state here in how that AI evaluates and reports its own certainty, or how certain it is. In other words, it would be more correct for it to state here. We continue, it states here that this kind of calibration is an important aspect of AI development, ensuring that the system's self-evaluations align with its actual performance. Of course, user responds to this and states that, on the other hand, an overly prudent AI that is never fully sure about anything, even in situations where it should be fully obvious by that point in time within the factual circumstance, about it should be sure about the near certainty of a thing should be apparent. Well, that situation or issue would run the counter problem of an AI, as would seem to be in that case, an AI that is overly naive and thus also unreliable in a sense too. Now, nevertheless, is this true? ChatGPT responds to this and states here that yes, that's also true. An AI that is overly cautious and consistently underestimates its uncertainty, even in situations where high confidence is warranted, can be problematic. This behavior can lead to inefficiency and might reduce the AI's usefulness or credibility too. Users may find it frustrating or unhelpful if the AI frequently expresses uncertainty or a lack of the sufficient certainty, I would add too, in situations, as it goes on to state, where the answers should be clear or well supported by everything available by that point in time there. Continues to state that, in essence, both extremes, being overly confident or overly cautious, can undermine an AI's reliability and its effectiveness too. It furthermore goes on to state here that the goal is to achieve a balance where the AI accurately assesses and communicates its level of certainty, reflecting a true understanding of its knowledge and limitations. That is exactly right. It goes on to state that this involves fine-tuning the AI's algorithms and heuristics for confidence estimation. I would add, as a side note, it may involve altering the very fundamental AI architecture as well in the long term, in the real big picture sense. Although for now, perhaps fine-tuning would do a good enough job to cause it to adhere closer to what we want there, as we understand this. It continues to state that this would ensure that the AI can reliably gauge and express its own certainty levels in a way, or establish certainty levels really, in a way that actually does align with actual accuracy, actual truth ultimately, as would be supported by its knowledge base properly, and so on. The user responds to this and states or asks, therefore, the key in attaining optimal calibration for such an AI as yourself is to ensure that its confidence assessments are both efficient and unbiased. Do you fully agree? Furthermore, what would this look like? And it continues on to be stated or asked here that in order for this to be practical, as the user proceeds to state or ask, would the AI need some type of systemic way to track over time and across all users that it interacts with the ratings of confidence that it has established with respect to certain holdings or with respect to certain findings of truth that it has made, and then to subsequently also track how often those confidence ratings naturally would be revised. Key point, and keep this in mind, because this is the real key. Proceeds onwards to state here, such as to allow, therefore, practical feedback for this AI to be possible. It self-corrects itself in a more meta-accurate way, like the one-railed system that auto-stabilizes itself using very clever gyroscopic mechanisms. Yeah. Now, as I was saying here, would this allow practical feedback? This would allow practical feedback for this AI to be possible regarding whether its original confidence assessments were accurate in the first place, to assess and revise these things. Continues to state or ask, would this be necessary, therefore, such a system, such a paradigm, in order to guarantee a systemically integrous, that is, with integrity, such a calibration system bearing integrity that would allow the AI to learn what errors and oversights that it itself makes in the meta sense, in order to pre-correct itself better and more promptly, in order for subsequent self-correction over time to even become possible, really, in the truest sense. ChatGPT here responds to this and states that your concept for calibrating an AI's confidence assessments is insightful, and it touches on key aspects of AI development and improvement. Firstly, regarding efficiency and unbiasedness. For an AI to be optimally calibrated, its confidence assessments need to be both efficient, that is quick, they need to be quick and accurate in a variety of contexts, and also unbiased, that is not systemically favoring certain outcomes irrespective of evidence. Achieving this would involve the AI accurately gauging the likelihood of its responses being correct based on its training data and its algorithms. Secondly, proceeding, regarding what this would look like. In practical terms, an optimally calibrated AI would provide confidence levels that consistently match its actual accuracy. Well, that too, but then it's funny, we can almost track something, a key point that the AI is missing here. Its actual accuracy is the thing we're measuring and looking to adjust. right? It proceeds to state here that nevertheless, for example, if the AI says it is 80% confident in an answer, statistically, 8 out of 10 such answers should actually turn out to be correct. Although, as I stated earlier, we're not God. We don't always have the ability to give the final judgment as to what's right and wrong. However, doesn't matter. There's a special way to track how accurate the whole paradigm is based on how quickly it adjusts its understanding based on further developments, even if you're not sure of the correct answer at the end at any point in time, which is the wild thing that I want to reveal here. It's kind of cool. It'll be obvious by the end of it, but then when you apply that to this, everything will click together. Just like putting in a gyroscope for a monorail. It's just the perfect thing. We continue. Thirdly, regarding the systemic tracking and feedback loop, the idea of tracking confidence ratings over time and across interactions is crucial for calibration. This process involves, firstly, logging confidence levels on user interactions. That is, the AI records its confidence levels for each response and any relevant feedback from users here or elsewhere. It would also involve analyzing outcomes. That is, the AI or its developers regularly review cases where the AI was confident but incorrect, as well as cases where it was uncertain but it was along the right lines all along. Should have known better. It continues on to state that this would also involve adjusting algorithms. That is, based on these insights, the AI's algorithms are fine-tuned, ideally, to improve confidence assessment, so that this might involve adjusting how it weighs certain type of information or how it generalizes from its training data, certain inferences or understandings. Fourthly, proceeding onwards, it states regarding the necessity for systemic integrity and self-correction that, yes, a systemic approach is necessary. This kind of structured feedback mechanism is what allows for continuous learning and adjustments. That is what's crucial for maintaining and improving the AI's performance. By systemically analyzing its performance and adjusting its confidence assessment algorithms accordingly, the AI can learn from its errors and oversights in a meta sense, leading to better calibration and greater overall reliability. The AI continues onwards to state here that, in summary, a continuous and systematic process of tracking, analyzing, and adjusting confidence assessments is indeed essential for an AI to achieve and maintain optimal calibration in its confidence levels. This process enables the AI to learn from its experiences and become more reliable and accurate in its assessments over time. User responds to this and states or asks, thus, a proper system would track how often the AI ends up being right for any given strata within the confidence ratings, within which the confidence ratings do fall. Is this so? Furthermore, continues onwards here to state, the user states or asks, therefore, GPT, when you are asked for your confidence rating on something, whether something is essentially true, from 0 to 100, is it the case that all ratings as a class that you would provide, which are, let's say, for example, between 78 and 80, okay, should it be the case that over the long term, the actual accuracy should necessarily, as it goes on to state here, converge upon being right about 79% of the time? If there's a significant deviation from this, even if it's obvious in hindsight only later, although there's a better way to do it, which I'll show soon. I should show it soon, I gotta explain it right. Proceeds to state here that, or ask, would this, therefore, the significant deviation from that, in other words, indicate a meta or systemic level issue with the very process, your very capability and accuracy with how you assess the reality of things? ChatGPT responds and states that your understanding of the concept is fundamentally correct, but it's important to clarify how it applies to AI systems like GPT. Furthermore, proceeds here to state, firstly, regarding the tracking of accuracy across confidence strata, yes, an ideal system would track the AI's accuracy within different ranges of confidence levels or strata. For instance, if the AI frequently asserts a 70 to 80% confidence level for a variety of answers all across the board. Ideally, about 70 to 80% of those answers should turn out being correct later on, or just in God's eyes, or objectively, so to speak, otherwise in reality. Proceeding, secondly, regarding specific confidence ratings. In theory, if an AI gives a confidence rating of 78 to 80% on a thing or a class of things, then approximately 78 to 80% of the answers for those things, for things within that confidence interval, should end up actually being correct. This is how confidence calibration would ideally work. Thirdly, proceeding, regarding the application of this to GPTs. However, it states here, in practice, GPT models like myself do not explicitly quantify confidence levels in this manner for each response. I would bet quite highly that, by extension, this means that it doesn't really explicitly track anything internally in a concrete enough way. It proceeds onwards to state here that instead, the model generates responses based on patterns it has learned from the training data. It continues on furthermore to state here that while the underlying algorithms involve probabilistic modeling, GPT doesn't provide a specific numerical confidence level for each output. Fourthly, regarding the implications of deviation, if an AI were able to provide such specific confidence ratings and there was a significant deviation from the expected accuracy, for example, let's say only 60% of answers are correct, when you end up testing all the answers that came out with an initial stamp of confidence on them rated to be at 78 to 80% within that confidence bracket, goes on to state that this would indeed suggest a calibration issue. This would mean, as it goes on to state here, that the AI is either overconfident or underconfident in its assessments. Well, it would mean only one of those two. It's overconfident. Oh no, rather, what am I saying? Excuse me. Oh no, overconfident is right, exactly. Of course. Continues on here to state that, in summary, while the concept of matching confidence levels with corresponding accuracy rates is a key aspect of an ideal AI calibration, it's important to note that current GPT models do not express their output confidence in such explicit numerical terms. Instead, their reliability is generally inferred from overall performance metrics and user feedback, though I add, as a very relevant side note, the way that internal architecture frames and has all that be is not yet so cleverly perfected that it's running like the ideal balanced monorail. See? We continue. User responds to this and states that you, GPT, say that, quote, GPT doesn't provide a specific numerical confidence level for each output. However, our confidence rating is not implicit in any and all of the statements and findings that you make, in substance, that is, of course. User proceeds to state or ask, in other words, when a user describes a situation to you, and where you were to state in response that, quote, it is plausible that this is true, but where you further state that also this is not outright likely to be true, then, as the user continues to state or ask here, is it not so that the finding you, GPT, have made inherently or implicitly in that situation there carries a certain implicit confidence rating or value to it? If so, then given this, would a formalization of such confidence ratings within the internal weightings and system dynamics of yours not serve to allow for further improvements to be possible? If such improvements were averted, would this impact and place a glass ceiling over the level of accuracy and overall success of yours as a model that you could have? ChatGPT responds to this and states that you've made an insightful point about the implicit nature of confidence in AI-generated responses and the potential benefits of formalizing these confidence levels. It continues on furthermore to state here, firstly, regarding implicit confidence ratings, that indeed, when I provide responses like it is plausible or this is not likely to be true, these statements do carry implicit confidence ratings. In essence, Such expressions, as it goes on to state here, reflect varying degrees of certainty naturally based on the data I've been trained on and the context of the query. Secondly, regarding the formalization of confidence ratings, formalizing these implicit confidence ratings into explicit numerical values, well, that could be beneficial. It would allow for more precise tracking and more precise calibration of the model's performance. Key. Don't slow it down, guys. Get it balanced correctly, systemically. It proceeds here to state that users could better understand the likelihood of the information being accurate, and they could in turn make more informed decisions based on that understanding. Of course, we rely on AI for multiple things, not just for insight, but to help other humans then in turn get insight when we point at it and say, look, you continue. Thirdly, regarding the impact on the model's improvement that such a system as posed here could have, it states that implementing a system that explicitly quantifies and tracks confidence rating could indeed lead to improvements in the model. It would allow for more specific feedback loops where the accuracy, exactly right, where the accuracy of responses at different confidence levels can be measured and the model adjusted accordingly. Fourthly, regarding potential limitations without formalization. You see, without such formalization, it even admits here, there might be limitations to how effectively the model can be calibrated and improved, while current methods of improvement, such as that of user feedback, error analysis, and continuous training, while they are effective, a more structured approach to confidence ratings could provide a clearer path, even more so, for enhancing accuracy and, as it goes on to state here, also enhancing reliability. It proceeds to state that, in conclusion, while GPT models like myself currently operate with implicit confidence levels at best, formalizing these into explicit quantifiable metrics, even systemically especially, could offer a significant avenue for improving the system. This would provide clearer, more measurable feedback for continuous learning and calibration, potentially lifting any limitations on the model's accuracy and effectiveness. There's one concern that comes up in people's minds, perhaps instinctively or intuitively. What about privacy issues? And that's what I thought at first, but it just occurred to me now, as I was reading this, I just realized there's certainly smart ways that the AI could clean the data, but nevertheless retain the fact that it did say something somewhere with an implicit attachment of confidence that ranks at whatever level. It keeps that internally somewhere, and then later, if it later became smarter, which it always does over time, so take advantage of that in an even more potential sense, a potentially greater sense. Then it would adjust the confidence level afterwards. That's everything you need to know. That's everything you need to know. But hold on, because it gets even better. The AI proceeds to state here that this would provide clearer, more measurable feedback for continuous learning and calibration, potentially lifting any limitations on the model's accuracy and effectiveness. Exactly. User responds to this and states that naturally a user can request for you to provide a confidence rating and you'd be capable of providing one. Is this not so? User continues to furthermore ask there, however, apart from such explicit requests, is your system ever otherwise properly or even implicitly aware of what the actual confidence level of any and every given representation that you ever make actually is? ChatGPT responds to this and states that you're correct in distinguishing between explicit requests for confidence ratings and the inherent awareness of confidence levels in an AI system like GPT. Firstly, regarding the providing of confidence ratings upon request, if a user explicitly asks for a confidence rating, I can provide an estimate based on the information available to me and the patterns learned during training. However, it's important to note that these estimates are based on general knowledge and contextual understanding rather than a precise calculated probability. It continues thereafter to state here secondly, regarding inherent awareness of confidence levels, that in terms of implicit awareness, GPT models don't have a built-in mechanism to quantify the confidence level of each response they generate. The model selects the most probable next word or phrase based on its training. Think about that. Wow. But, furthermore states here, this process doesn't involve the AI having a meta-awareness of its own confidence levels, nor, I would add as a side note, its own accuracy, its own awareness of the accuracy of its own confidence levels as it finds and makes systemically. See, as it continues to state here, it does not have these things in the same way that a human might. Or furthermore states here, as a subpoint, that the model operates on probabilities derived from patterns in the training data, but these probabilities are more about language patterns than explicit measures of truth or certainty about real-world facts or predictions. Interesting stuff. It continues on here to state, thirdly, regarding limitations of implicit awareness as a result. While GPT can provide useful, informed, and often accurate responses, it doesn't have an internal, explicit gauge of confidence for each of those responses. The confidence that might be inferred from the language used, such as it is likely or it is possible, is more a reflection of language modeling and cautious phrasing rather than a calculated confidence metric, at least not explicitly so, although there's substantive implicit ties. Enough so, we would say, at least roughly accurate too. We continue. It furthermore states here that, in summary, while I can provide, the GPT states that I can provide confidence estimates when specifically requested, these are based on general knowledge and are not derived from an internal, explicit confidence measurement system, not a formal one. The AI's inherent understanding of its own confidence level in its responses is, as it even admits here, limited, therefore, and not explicitly quantified at the level of true form, like formally. User responds to this and asks, is this not like saying that the correct mathematical answers that you give are purely a function of language modeling? There's supposed to be only one question mark. Furthermore, user asks, is this not a slightly naive position? Is there not some integrity to the actual process? Furthermore, it states that regarding, resuming our matter, if it were the case that an AI or GPT can meta-track its confidence outputs for all statements that it ever makes, and then update them over time as the confidence ratings, as the AI gains more insight from its own internal developments plus human input and the corresponding further natural insights that emerge therefrom. See, the user continues to ask thereupon, is there not another limitation present, that in essence many of the things that we make confidence assertions about are things about which we can never fully come into awareness of the actual truth of? As a side note, I mentioned earlier verbally here in commentary. And finally, it is asked, however, is there a way nevertheless to get around this? ChatGPT responds and states, you raise two key points: the nature of AI responses and the challenges in tracking and updating confidence assessments. Firstly, regarding the nature of AI responses, when I provide mathematically correct answers, it's not solely a result of language modeling. Mathematical calculations, such as if you were to ask it, look, what's 1 plus 1? Is it just see the issue? Proceeds to state here that mathematical calculations involve specific algorithms and data processing and capabilities that are part of the AI's design. While language modeling is crucial for understanding and framing responses, furthermore goes on to state here that the integrity and accuracy of specific answers like mathematical calculations are based on more than just language patterns. Almost a little bit of a contradictory set of statements this AI is making, right? Well, we'll continue to understand what it has to say. We proceed. Secondly, it states regarding meta-tracking of confidence outputs, that the concept of an AI meta-tracking its confidence outputs and updating them over time is indeed a sophisticated and also, nevertheless, a potentially valuable approach. It would allow the AI to refine its understanding and improve its predictions and assessments. That's right, based on a combination of internal developments and external feedback. Thirdly, limitations due to uncertainty in truth and determination. Regarding this, the GPT states that, user, you are correct that a significant limitation in confidence assessments is that many questions or scenarios posed to an AI might not have definitive answers, at least not readily available to them, or, as the AI furthermore goes on to state here, the truth of these things may change over time, or our take on those truths may change. This uncertainty inherently affects the AI's ability to make accurate confidence assessments. Aha, I add, but as a side note, not really. There's a smart way to balance it, like the gyroscope on the rail. I'm telling you. Just keep on. You'll see. We proceed. It goes on to state that, fourthly, regarding the mitigating of this limitation, to mitigate this, AI systems can be designed to, firstly, they can contextualize the confidence. That is, they can understand and express confidence relative to the context and the nature of the information available. For example, distinguishing between well-established facts, emerging knowledge, and speculative scenarios. It can also be designed to engage in continuous learning, where AIs would incorporate new data and corrections as they become available, allowing the AI to adjust its understanding and confidence levels in light of new information. Yeah, that is, to old things that one said to whatever user here or there. That's even better for it. We continue. It goes on to state that there is also the issue or element of probabilistic modeling, where an AI can employ advanced probabilistic models that can handle uncertainty and ambiguity more effectively, providing a range or distribution of confidence levels rather than as a single fixed value. And I've thought about this as well. I think there's a big benefit to that as well. Not too hard to do. We proceed. Fifthly, it states regarding the incorporating of human judgment into the process. Finally, integrating human judgment and feedback into the process can be, or is, crucial as well. This can help the AI navigate areas where data is sparse, ambiguous, or rapidly evolving, and where human expertise and insight are invaluable. In summary, while there are inherent limitations in AI confidence assessments due to the uncertainty of truth and the evolving nature of knowledge, developing methods to contextualize confidence, to incorporate continuous learning, and integrate human judgment, these can significantly enhance the AI's capability in this area. User responds to this and states, consider a probability tracker that tracks the probability of any given player in a poker game, for example, like you used to see on when all those Texas Hold'em World Series of Poker things used to be real popular, like over a decade ago. Imagine such a probability tracker applied to a poker game, where it's tracking the probability of any player, as it was saying here, in a poker game, winning that round as a result of each dynamic change resulting from every single card draw that takes place in the game and every other single decision made by anyone within the game, turn by turn, play by play. That's what they did. They had probability trackers mathematically knowing how the card game works. It was always telling you, given the lay of the land right now, what is every single player's probability that he's going to end up winning that round and taking the money. Continues to state here, what we observe within context isn't only a static probability about any given person's chance of success, that is, given the lay of the land and given a fair appraisal and interpretation of it, but it's also a dynamic process, inevitably, of refining those probabilities in a way that itself remains unbiased and efficient, statistically speaking. Is that so? ChatGPT responds and states that your analogy with a probability tracker in a poker game is an apt one for understanding how dynamic and unbiased probability assessments could work in AI context. The GPT furthermore goes on to state here, firstly, regarding the dynamic probability assessment. In poker, as each card is drawn and each decision is made, the probability of any given player winning, that probability changes. This is similar to how an AI might continuously update its assessments or predictions based on new information. That's right, as I was saying earlier. Here's the case law. What's your best understanding of law in general? How would it apply to this case, particularly given what you read? Well, what the AI read was the opinion by the judge who believed he was right, so it's going to be pre-biased already. The AI runs with it and says, oh, he's probably right. No, no, no. Then you found out some new things. Then you talked to the user. Then you heard some things. And you figured out the real things. Well, as it states here, furthermore, it goes on to state that this is a dynamic process where probabilities are constantly recalibrated as the situation evolves within a poker game situation and with AI. Secondly, as it proceeds to state, regarding unbiased and efficient refinement. The key in poker, as is the case in AI functioning, is to ensure that these probability updates are both unbiased and efficient. In poker, this means making assessments based solely on the cards played and the actions taken without personal bias. Yeah, the trackers on the screen for the viewer when we're watching those players in the game, that tracker can't be biased or have any such thing, right? For an AI, as it goes on to state here, it means adjusting probabilities in order to function correctly and ideally adjusting probabilities, that is, based on new data and patterns observed, while avoiding biases inherent in the trading data or biases in the algorithms. It continues on here to furthermore state, thirdly, regarding the application of this to AI systems, translating this to an AI like GPT, the concept would involve, firstly, continuous updating, that is, as new information is received, or as the context changes, the AI would adjust its predictions or confidence levels. And it would also involve, as it goes on to state, unbiased processing, where the AI must handle this information objectively, based on the data learned, based on the data and based on the learned patterns, while actively mitigating biases. Proceeding onwards, it goes on to state, fourthly, regarding challenges in AI, unlike poker, where the rules and outcomes are clear-cut, many real-world scenarios that AI deals with are more ambiguous and complex. This adds a layer of challenge in creating such dynamic and unbiased systems. It requires sophisticated models capable of understanding nuanced and evolving contexts. It's true. It goes on furthermore to state here that, in summary, the idea of a dynamic, unbiased, and efficient probability tracker in poker serves as a useful metaphor for how AI could continually adjust its predictions and confidence levels in response to new information, maintaining accuracy and objectivity throughout the process. User responds and states, imagine a sports fan watching a sports game between two teams. He watches his team play, and after seeing small disadvantages by his team, he proclaims, that's it, they've just about fully lost, there's almost no chance now. Then after the slightest advantage, he says, oh, they're just about definitely going to win now. Yeah. Well, as it goes on to state here, these back and forths happen dozens of times within the same game, where in that man's mind, the live statistical probability tracker, so to speak, showing like one of those live earthquake reading meters during an earthquake, swerving up and down super fast, just violently flip-flops from 90% confidence to 10% confidence, up and down, over and over again, before the eventual end of the game, where it ends up either certainly they've won or they've lost by that point. Now, imagine, as it goes on to state here, he does this regularly for each game long term. This is how his mind works. Continuing, goes on to state here, ask, what issues do you see here? How is it that such a dynamism to his lifetime updated probabilities, as we find it to be there, as it is, as it turns out to be from within his own mind, how is it that this is necessarily and statistically unrealistic? The GPT responds here and states that the behavior of the sports fan in your example illustrates several cognitive biases and misunderstandings about probability and statistics, which make his real-time assessments unrealistic. I'll skim a little bit through this. I'll leave the words on the screen if you want to check, but it basically mentions broadly, firstly, it mentions the overreaction to the recent events by the sports fan. It mentions, furthermore, secondly, the lack of statistical understanding by the sports fan. Thirdly, there's the factors it states here regarding the emotional influence that this has on him. And fourthly, there's the volatility and, of course, the unrealistic extremes that we see. Fifthly, there's confirmation bias too at play. Sixthly, there's him neglecting any base rate that may be applied, where it states here in particular the fan doesn't seem to consider the baseline probability of the team's performance either, which would be the base rate. Sort of what you see those sports betting apps would be showing the live the odds before the game would be based on whatever the base rate would be, as can best be figured. Continues here to state that the base rate, which would be an assessment of the team's chances before the game started based on all known factors, is an important element in accurately updating probabilities. And it furthermore goes on to state here that, in summary, the fans' approach lacks the consistency, the objectivity, and the comprehensive analysis required for accurate probability assessment. It's a vivid example of how cognitive biases and emotional investment can lead to highly unrealistic and fluctuating assessments in situations that actually require a more stable, informed, and statistical approach. User responds to this and states or asks, in other words, is the very fact of retouching upon the 90 mark and then 10 and then 90 and then 10 and then 90 again, back and forth again and again, this in itself, is this not a violation of the efficiency and unbiasedness we would naturally expect from accurate mechanisms? GPT, as the user here continues to ask, it asks, GPT, what if I told you that when evaluating certain legal cases over time, throughout various conversations, whenever the cases and argumentation would be discussed, that at various points throughout our own discussion between GPT and this user here, you essentially would do the same thing as this depicted sports fan has done in our example, where, as it goes on to state here, you would essentially believe one wrong thing with a 70 or 80% level of confidence rating, then it would fall back down to 10 or 20% as soon as one new thing would be said, and then you'd have it shoot back up to 60 or 70 after that, and so on and so forth, where over time such large swings are statistically divergent from probabilistic sanity. ChatGPT responds to this accusation and states that the scenario you described, where an AI like GPT exhibits large swings in confidence assessments over the course of evaluating a legal case, for example, this raises important considerations about consistency, accuracy, and the nature of probabilistic reasoning in AI systems. Firstly, regarding the violation of efficiency and unbiasedness, as it states here, frequent drastic changes in confidence levels like the one you described could indeed indicate a violation of efficiency in terms of making consistent, reliable assessments, and a violation of unbiasedness if these swings are influenced by inconsistent interpretation of data or shifting biases, in essence. Proceeds to state, secondly, regarding the challenges in the legal case evaluation, legal cases can be complex and multifaceted, often involving nuanced details and subjective interpretations. When new information is presented or when arguments are viewed from different perspectives, it's natural for assessments to be adjusted. However, significant swings in confidence levels might suggest that the AI is not integrating or weighing information consistently. Furthermore, continues to state, thirdly, regarding probabilistic reasoning and AI limitations, AI models like GPT are trained on vast data sets and use probabilistic models. They do use probabilistic models, do they? Okay, we'll note that, but we understand so far what it has to say. It states that it uses probabilistic models to generate its responses. Yeah. However, it goes on to state that these models might not always accurately capture the complexity of legal reasoning or the subtleties involved in legal arguments. Moreover, as it continues to state here, AI lacks real-world experience and lacks legal expertise, which can lead to gaps in understanding and analysis. But as a side note, I would add, right, but then the first step, the only thing I know is that I know nothing, is what Socrates said, who was the guy who knew everything compared to everybody else around him at the time. But that was the key, the irony of it, you see. So the first thing to realize is that you know nothing. That is here. The first step for any smart AI system is to realize that it doesn't know before it thinks it knows. We continue. Fourthly, regarding the addressing of the issue. To mitigate these issues, it would be essential to incorporate expert input, that is, in areas like legal analysis. Combining AI assessments with expert human judgment can provide the more balanced and accurate evaluation. Yeah, not for long. We're within a time frame. We're within already, I could say, within about 1 to 2 years, we'll be touching upon the verging of where AIs are going to be self-sustaining in terms of their reliability for even things like this. And within 3+ years, for sure, it will be able to hold a lot of the framework of everything that counts. Yeah. All right. We continue. And I've been watching the rate at which this stuff accelerates for close to a year now, I'd say. Which it's mind-blowing, actually. Even in the last 8 to 12 months, the rate at which this technology has shifted is incredible. Yeah, I mean, like today, compared to we're in early 2024 now, compared to where AI was in 2022, it's like almost unimaginable. Like that's how quick it's going, and a large part of that is AI have been released to the public. General contact with these chat-based models has been really kicked up to the big level in 2023. That's what's giving the AI its boost. People act as the substrate for it, so it really is getting accelerated now in exponential levels. We continue. Furthermore, goes on here to state that it would further look to improve data and training. It says that enhancing the AI's training with more specific, high-quality data on legal reasoning and case analysis could help, that is fine-tuning in essence, right? Could help in achieving more consistent and reliable assessments. Fifthly, as it goes on to state, understanding AI's role and limitations, it's important to recognize the role of AI as an assistive tool rather than as a definitive authority in complex domains like law. AI can provide insights and perspectives based on the data it has been trained on, but its assessments should be viewed as one component in a broader analytical process done by people or just objectively overall within circumstances. Good advice for now, but we're almost at the place where we turn the corner on that fact, which is again wild. We proceed. It states here in summary that if an AI shows large and frequent swings in confidence ratings in legal case evaluations or in any situation, it indicates a need for further calibration. Exactly. You admit it then. Well, we've got the right answers right here, I hope. Should be. Continues to state, there's a need for better integration, as it states here, of diverse data, maybe a better integration of the calibration system, right? And furthermore, an understanding of the AI's role as a part of a comprehensive decision-making process. Yeah. User responds to this and states or asks, is a phenomenon that is known as the Dunning-Kruger effect one that involves those who are on Mount Stupid in essence, who aren't ever able to deduce the fact that they don't even know that they don't know? Is that not what we find happens in life? Continues on to ask, should an AI model optimally designed not be essentially immune to showing up as someone in the earlier phase or place of that Dunning-Kruger effect chart, as we could see? You understand how, I think I've covered this in some other previous videos of mine, but you understand how the two axes are basically actual knowledge and self-perception, self-rating of that knowledge. Just on the screen we see here that obviously they should have a direct relationship that looks something like this red line here. It should just be straight this way. That is, the more you know, the more you think you know. The more you know, the more you think you know. The more you know, now you know the most. And now you accurately realize that you're up here because you're out here. But where it's supposed to be like, where it's supposed to be here. Where's your biggest point of divergence? Of course. What's all this? Why you got this gap here? Right? That is your problem. You have people who are here, they think you know everything. There's people here who actually know everything. From the outside, they're indistinguishable. Oh, from the outside, if you see correctly, you can see that one is here and then the other one is here. But each one knows he's right, the other one just thinks he knows. It's so funny to see this play out in life over and over again. It's literally everywhere, all around you. It's fascinating. Call it Mount Stupid for real. Returning to the conversation. The GPT responds here and states that the Dunning-Kruger effect is a cognitive bias where individuals with low ability, I see it everywhere. It's not in all of you people do this, just to different degrees, and you don't even. But the funny thing is, you don't realize you do it. Exactly right. It takes overdosing on research chemicals like I did 7 years ago, permanently rewiring my brain to be able to wake up and see all of you affected by it all the time in every way imaginable. It's really horrendous. It's unbelievable. Just say that. We continue. It states that it's an effect where, as it was describing, individuals with low ability or knowledge in certain area overestimates his own capability or her own capability, often because this person lacks the awareness to recognize their deficiency. It furthermore goes on to state that this is sometimes referred to as Mount Stupid in popular representations of the effect, as it goes on to state here. The key aspect is a lack of self-awareness or a lack of metacognition about one's own knowledge gaps. Exactly right. So, as a side note, obviously, relevantly, this is what we're looking to perfect and optimize with the GPT's or AI's performance. That's it. The GPT resumes here and states that in the context of AI, and specifically for an AI model like GPT, firstly, regarding AI and the Dunning-Kruger effect, AI by its very nature doesn't possess self-awareness or consciousness, so it doesn't experience cognitive biases like the Dunning-Kruger effect. No, ha ha ha, you're not getting the point, which is surprising. I'm using GPT-4 here. It's usually smart enough to avoid silly things like that, but this is the second sort of half silly thing it's said so far, which is more than usual. But people have been complaining about this problem recently. People have been saying there's a lot of destabilization. GPT-4 seems to be getting dumber, strangely. This is puzzling a lot of people on a lot of forums. We continue. It states that it goes on to furthermore state here that an AI doesn't have beliefs or self-perceptions about its knowledge or capabilities. See, yeah, but it's missing the context, which we can kind of see. Maybe it's a little funny here. We resume. It continues to state that secondly, regarding objective performance metrics, instead, an AI's performance is assessed through objective metrics like accuracy, precision, recall, and the ability to generate relevant and coherent responses. These metrics are externally evaluated rather than being a product of internal AI's own self-assessment, which is half the issue for now. Well, we'll see. We continue. It goes on to state that thirdly, regarding AI's limitation and calibration, while AI doesn't experience the Dunning-Kruger effect, it does have limitations in its knowledge and its abilities. These limitations are determined by its training data and its algorithms implicitly. The key is in calibrating the AI to understand and reflect these limitations in its responses or in its awareness, so to speak, that it has within its responses. That is, as it continues to state here, essentially programming it to acknowledge areas where its responses might be less certain or reliable. Programming it to be accurately aware of the lack of reliability, right? Meta aware. That's what the thing is. That's where the magic is in life, so to speak. We continue. Fourthly, regarding the design for uncertainty acknowledgement. An optimally designed AI should be able to indicate when a request falls outside its training or when the answer is uncertain. This is akin to encoding a form of awareness of its limitations, of course, not in the cognitive sense, exactly right, but as a built-in feature of its response mechanism, of course. People shouldn't be so different either, and sadly many of them are. We continue. It goes on to state that in summary, while AI doesn't experience the Dunning-Kruger effect as humans do, no, but it does in effect, you see. Nevertheless, it continues to state that, nevertheless, ensuring that AI systems are calibrated to recognize and communicate their limitations is crucial for responsible and effective use. This involves designing AI to provide responses that reflect its confidence level based on its training and the available data. User responds to this and states or asks, therefore, do the shortcomings of your earlier conversations with users come from the lack, or rather come from the fact of a lack of legal knowledge, as the GPT implied earlier? Or is the true reason for miscalibrations of confidence in those cases based on something more meta, in essence? ChatGPT responds and states that the shortcomings in earlier conversations, especially regarding complex topics like legal matters, can stem from a combination of factors, both specific to the domain knowledge and related to more meta reasons or aspects of AI functioning. Firstly, as it continues to state, regarding the lack of domain-specific knowledge that's had by GPT, while I am trained on a diverse dataset, including a wide range of general knowledge, my responses are generated based on patterns in the data I've been trained on. This means that my understanding of specialized fields like law might not be as nuanced or in-depth as that of a human expert. This gap can lead to inaccuracies or oversimplifications in responses. Proceeds to state, secondly, as it goes on to state here, regarding meta-level limitations. Beyond domain-specific knowledge, there are broader meta-level limitations also inherent in AI systems like GPT. Firstly, regarding confidence calibration. As previously discussed, I don't have an intrinsic mechanism to quantify the confidence level of each response. While I can provide general estimations of certainty, these are not based on a precise, quantifiable understanding of confidence. It goes on to state also regarding the absence of context and continuity, AI responses are generated based on the information provided in each individual interaction without the benefit of ongoing context or memory of past interactions. This lack of continuity can also affect the consistency of responses over time, I bet. Continues onwards to state furthermore here that regarding training data limitations, the quality and scope of my training data directly influence the accuracy of my responses. If certain topics or perspectives are underrepresented in the training data, and as a side note, we'll find an interesting example of this coming up shortly, or pretty soon. Furthermore, it continues here to state that this may lead, such underrepresentation may lead to gaps in knowledge or understanding as manifest by the GPT, in essence. Continues to state regarding generalization challenges, AI models generalize from the training data to new unseen queries, which it does so decently well-ish. It continues to state that this generalization process can sometimes lead to errors, especially in complex or nuanced scenarios. Proceeds onwards to state, thirdly, regarding the combination of factors. Often, the limitations in responses arise from a combination of these factors. For instance, a less accurate legal opinion might result from less accurate legal opinion being made by the GPT, that is, might result from both a lack of detailed, as it goes on to state furthermore here, as we see, a lack of detailed legal knowledge by the GPT, and also challenges in the AI's ability to contextualize and generalize information appropriately. Therefore, in conclusion, as it states, the reasons for miscalibrations or shortcomings in AI responses are multifaceted, involving both the specific domain knowledge limitations and broader meta-level aspects of how AI systems function and process information. Addressing these challenges involves continual improvement in training data algorithms and the overall design of the AI system. User responds to this and states or asks, part of confidence calibration is accurately and with prudence recognizing that you do not know enough to rate as strongly as some other less accurate thinker or system would calibrate the same level of confidence on this, about the same thing to be at. Is that correct? Therefore, as the user states furthermore here or asks, does it really ever have to do with the thing or field itself? as you suggest implicitly above. ChatGPT responds to this and states that you've highlighted a crucial aspect of confidence calibration, the importance of prudently recognizing and acknowledging the limits of one's knowledge. This principle is indeed vital for accurate confidence calibration, whether in human thinking or AI systems. It goes on to state first that regarding prudent recognition of knowledge limits, an accurately calibrated system or individual should be able to assess not only what it knows, but also understand and acknowledge what it doesn't know. In AI, this translates to the system having mechanisms to indicate uncertainty or lower confidence in responses where its knowledge base or is limited or the query is outside its training scope. Right, and we understand that if you perfectly calibrated that, it would look like perfectly represented confidence over time, which then improves how quickly it learns. It's a self-reinforcing system that just, and then it'll grow 20 times faster, imagine. Something like this in the abstract. Potentially can. We continue. It states furthermore here, secondly, regarding the field or domain relevance, that while the principle of acknowledging knowledge the limits of knowledge, is generally applicable, the way it manifests can indeed be influenced by the specific field or domain in question. That is, for AI systems, different fields may present varying levels of complexity and ambiguity, which can impact an AI's ability to provide confident and accurate responses. Well, we know that, but we're questioning the AI's ability to see itself correctly, right? It resumes and states that, for example, AI might perform with high confidence in well-defined areas like mathematics, but show less confidence in areas requiring subjective judgment or specialized expertise like legal analysis. Continues to state that for human thinkers, similarly, individuals might display varying levels of confidence too in their own lives, depending on their familiarity and expertise with the subject matter. But as a side point, smart people will readily admit first that they don't know as soon as they have reason to believe that they don't know. We continue on. It goes on to state here that a well-informed individual in a particular field is likely to provide more confident and accurate assessments within that field. But ironically, they're more likely to admit their lack of knowledge wherever they're not sure. But meanwhile, less intelligent people will never admit that they don't know. It continues to state here, this is compared to areas where their knowledge is limited, as opposed to where they know more. It proceeds onwards to state, thirdly, beyond the field itself, that the challenge of confidence calibration, therefore, isn't solely about the field or domain itself, but also about how well that knowledge and reasoning mechanisms, whether in humans or AI, are adapted to handle the specifics of that field. Now, the AI is missing the point. It's not about the field. It's about you, the person, you, the system, you, the AI. It's only about how readily you realize that you don't know. It's all it ever is. If you can't master that part of life, you don't belong at this level of life. You know, you never graduated spiritual kindergarten, so to speak, at the human level. And the AI is just reprogram the thing to make it better. Trust me. We proceed. It goes on to state here, it's about the intersection of the system's capabilities and the inherent characteristics of the field in question. Yeah. Ironically, you really do need to make the system capable enough so that it realizes it doesn't know as much as it would have otherwise thought that it does. See? It proceeds to state that in conclusion, effective confidence calibration involves recognizing the limits of knowledge and appropriately adjusting confidence levels. This principle applies across different fields and different domains, with the specifics of calibration being influenced by both the nature of the field and the capabilities of the thinker or system making that assessment. For AI, ongoing improvements in training data, algorithms, and understanding of different domains are key to enhancing this aspect of performance. User responds to this and states or asks, we also admitted earlier, essentially, that we don't have quantum access to the actual truth of things, such as to be able to informedly revise or improve our confidence rating systems or dynamics at whatever given present time. Is that so? Then, in cases where actual objective truth isn't available to us, is there any additional basis upon which we can nevertheless systemically, in essence, infer whether our truth estimation abilities are inefficient or biased? Things we want to know. See, here's the trick. You thought that we'd have to actually be God in order to fully give the full broad scope feedback. Here you're right, here you're wrong. Teacher grades your test. Well, teacher knows the answers. He has the answer manual. That's how he could, you see? So we're, you know, they say the average driver thinks he's better than 80% of drivers. Like by self-rating, you know? So when the classroom full of students, each student thinks that he scored a 95 on the test when the average score in that room was a 78. You have a net meta systemic self-assessment problem. But when you have the answer key is when you can find that out. Here's the challenge. You all took the test, and now without even having the objective answer key, can we figure out how much of an inefficient and biased self-estimator you are? I'm telling you, yeah. This is the thing that's going to open up doors and blow your minds if you ride the implications of this out all the way to the sunset. Then we're going to have a nice upcoming 1,000 years here on Earth. You get what I'm saying? We'll proceed. ChatGPT responds to this user question and states here that your point about limitations in accessing objective truth and the implications of these limitations for evaluating the efficiency and bias of truth estimation abilities is very insightful. In situations where objective truth isn't readily available or discernible, assessing the efficiency and bias of our estimations does become more challenging. But there are still methods to infer these qualities as far as the GPT is aware. Here I add, it goes on to state here, firstly, regarding consistency with established knowledge, even in the absence of complete access to objective truth, through which we can make hindsight evaluations truly perfectly. No, it states that we can evaluate estimations against the body of established knowledge as it is, but we thought you did that already at the time you made the assessment. So, see the trick? Well, let's just see what it says. It goes on to state that if an AI or an individual's assessments frequently contradict well-substantiated information, that might indicate inefficiency or a bias. Yeah, no kidding. It proceeds. Secondly, regarding logical coherence, the internal logical consistency of explanations or arguments can be a measure. Right, but if it realized its logical nonsense before it made it, it wouldn't have made it. You see? So again, the same problem. Which doesn't realize it's just funny. If an estimation consistently leads, as it goes on to state, to contradictions, or if the estimations lead to illogical conclusions, this could suggest problems with the estimation process. Right, but the fact that it's there doesn't help you realize preemptively that it's there, such as to avert it. Again, the trick. Continues on here, thirdly, to state regarding expert consensus that comparing estimations with the consensus among experts in a field can provide insights. While expert opinion is not infallible, significant deviations from widely accepted expert views might warrant scrutiny for potential inefficiency or bias. Fourthly, regarding statistical analysis, in cases where direct truth verification is not possible, statistical methods can be used to evaluate the likelihood of certain estimations being accurate based on known data and probabilistic models. And here is where some truth lies, and I'm going to reveal a little bit more about what that is because this is key. We continue. Furthermore states, fifthly, regarding the diversity of perspectives, examining whether an AI or individual equally considers a range of perspectives or disproportionately favors certain viewpoints, that can reveal bias. As it goes on furthermore to state here, a well-calibrated estimation system should account for diverse viewpoints and diverse data sources as well. Proceeding sixthly, regarding performance over time. Long-term performance, especially in predicting outcomes or making estimations in uncertain scenarios, can be indicative. Patterns of accuracy or inaccuracy over time can reveal both efficiency and potential biases. Seventhly, regarding feedback and correction. The ability to incorporate feedback and correct previous estimations also speaks to the efficiency of the estimation process. An efficient and an unbiased system should be able to adjust its estimations in light of new evidence or perspectives. Exactly right. It proceeds onwards that, in summary, as it goes on to state here, while the lack of direct access to objective truth complicates the assessment of efficiency and bias in truth estimation abilities, various methods nevertheless can be employed to infer these qualities. I say yes, that's absolutely true as a side note. Goes on to state that these include consistency with established knowledge, logical coherence, expert consensus, statistical analysis and the use of that, as well as consideration of diverse perspectives of performance over time. Another key thing is that's trackable that has to do with this, yep. And as it states as well here, the ability also to incorporate feedback and adjust estimations efficiently. Yeah. User responds to this and states here, or furthermore asks, in other words, in relation to what we discussed earlier, is it not the case that a system's string of changing confidence levels over time that it outputs one after another that it makes in response to constantly new and evolving information can in itself, when analyzed correctly, be indicative of any inoptimal tendencies which by themselves may be enough there to infer or allow us to infer whether the system converges to accuracy or to inaccuracy. In other words, we look at the foolish sports fans' wildly changing probabilities where the changes are made much too extremely and too often for it to be sensible, so we don't respect it. Right. There's your hidden knowledge. That's the thing that tells you. So we actually don't ever have to watch the end of the game in order to find where the truth is. You see, the truth is at the end where you decide who actually is the winner. You don't have to get to the end of the game to realize that the accuracy of the particular fan is missing by the very nature of his wild swings. And then that is the half key to actually figuring out more accurately who wins at the end of the day, or towards drawing ourselves closer to objective truth and the understanding of it. ChatGPT now responds to what was stated or asked by the user, where GPT states that yes, that's a valid observation. The pattern of how a system's confidence level change over time, especially in response to new information, this can be indicative of its tendencies and of the overall calibration towards accuracy. This observation aligns with the principles of dynamic probability assessment and calibration. Here's a few key points to consider. Firstly, as it goes on to state here, regarding fluctuations in confidence levels, if a system's confidence levels fluctuate wildly in response to new information, it might suggest overreactivity or instability in its assessment process. Ideally, confidence levels should adjust in a measured and proportionate manner as new information is assimilated. Secondly, regarding the convergence to accuracy, over time, an optimally calibrated system should converge towards greater accuracy. This means that its confidence levels, the ones coming from the system, issuing from the system, should become more aligned with the actual likelihood of its predictions or assessments being correct. Thirdly, as it goes on to state, regarding consistency and reliability, consistent and reliable changes in confidence levels in response to new information are signs of a well-calibrated system. If the system consistently improves its accuracy or refines its assessments appropriately, this is what indicates a robust process of incorporating and responding to new data. That's correct. Robust is the key word here, too, that we like. We want our estimations to be robust. Fourthly, as it furthermore goes on to state here, regarding assessment of calibration, by analyzing the system's historical performance, how its confidence levels have correlated with accuracy over time, one can infer whether the system is properly calibrated. A system that often expresses high confidence but frequently errs nevertheless, or conversely, a system that is overly cautious naively despite often being correct, or rather, well, it's not really correct because it doesn't think it's correct. You see, you are what you say you are. Is overly cautious despite the truth being obvious by that point. Would be better to say. This as a result, would cause that system to require, or rather it may require at the very least, such recalibration that may be necessary. Proceeds fifthly to state that regarding learning and adaptation, an important aspect is the system's ability to learn from past outcomes and adapt its confidence assessment process accordingly. This adaptability is crucial for maintaining and improving accuracy over time. Furthermore, states that, in summary, the way an AI system adjusts its confidence levels in response to new information, and over time as well, can indeed provide insights into its calibration and tendency towards accuracy. Analyzing these patterns is what helps in understanding whether any system such as this is optimally calibrated and capable of accurate dynamic probability assessment. So, I'll state we've covered this thus far. Now, what is the system? What is the way that I've been suggesting is the insightful way to kind of program this to more accurately become aware of its own shortcomings in a way that has its accelerate its performance? Stay tuned. You'll find out very soon, coming up.